So I assume that you have already watched videos based on differentiation or videos of differentiation, because there are about 20 videos. Without watching those 20 videos, understanding integration might be a little difficult, because integration has two types of interpretations. Integration, so one is about area under a curve, and antiderivative. Antiderivative. Antiderivative means derivative is differentiation. So antiderivative, derivative of a function means differentiation of a function. Antiderivative means integration. So in this aspect, I'm going to define integration, because area under the curve, you will do it extensively in your mathematics part. So first, but anyway, we will start with area under a curve. Antiderivative, in the sense, it is something like this. For every mathematical operation, there is an inverse operation. For example, addition, the inverse is subtraction; multiplication, the inverse is division. So in the same fashion, for derivative, that is antiderivative. So in that way, the inverse of derivative is antiderivative, and that is called integration. So let's look into the first thing. What is area under the curve? Suppose that you have y-axis and x-axis, and there is a function of x. Suppose y is here and x is here. Let us say that y is equal to x cube plus, let us say, minus x or something plus 3. And we don't know, like, I don't know exactly the curve, but still roughly. So then this y is called a function of x. So we are writing y is equal to f of x. Okay, the curve may look like this. Supposing that the curve may look like this. Okay, so what is the area under the curve? Suppose you have like this, very similarly like this, one curve is like this. Then this is the f of x, the height, and the base is the x-axis. Then this area equal to f of x into x. But here the height of the curve keeps on changing according to the function f of x. Then in order to find the area of this curve, it is better to divide this entire area into tiny rectangles. So here these rectangles do not look very tiny, because when you want to do it, there is a gap. Suppose if you make this a rectangle, there is a gap. But when you make this rectangles so very small, suppose the base, let us say the value of the small change in value of x is dx, and this function here is f of x. The equation of this function is f of x. So if you want to find out that area here, if you want to find out this area, the rectangular area, it is like f of x dx. What is that? That is area of this small portion. Let us call it dA. So dA is the area of the small portion, and that is equal to f of x, which will give you the height of that curve at that point, and dx is the base. So base into height. But to find the total area, you have to find the area of each rectangle and add it. So the total area from this is, total area is equal to summation of this f of x dx, starting from here to here. So that we call limit. See, suppose if there are n number of rectangles from here to here, if there are n number of rectangles from here to here, f of x dx you are going to do from 1 to n. But see, there is a trouble with this. Whenever you make a small rectangle, this is not a perfect rectangle. So if you make the number of rectangles so much, like so many and almost infinite number, when you make infinite number of rectangles, then n tends to infinity. That time we bring in the notion of integration. when there are infinite number of rectangles to be added, this summation 1 to infinity is replaced by this symbol called integration. Integration of f of x dx. So this is called area. So what is the function of x's integration? Suppose f of x dx is said to be f of x. F of x dx is said to be f of x. Then see, don't worry if you don't understand, because you just keep on listening to what I'm saying. So when we go into an example, you will understand it much better. So the f of x dx is equal to f of x. So integral of f of x is f of x provided f dash of x is f of x. One example is integral of x to x square, integral of, okay, I'll give another example. Like, suppose our f of x is equal to x cube. Then what is f dash of x? F dash of x is equal to d by dx of f of x. What is d by dx of f of x? D by dx of f of x is x cube. Then this x cube means d by dx of x cube is 3x square. So the differentiation of or you can say that derivative of x cube is 3x square. That means integral of 3x square dx must be equal to x cube. This is what the meaning of this statement. What is that? If f of x dx is capital F of x, provided the differentiation of this must be this. If the differentiation of the result is this function, then this function's integration value is this. This is what the meaning. So this is like antiderivative. So integration is the antiderivative. Okay, but there is a trouble to this. For example, if f of x is equal to x cube plus 5, then what is f dash of x? F dash of x is d by dx of f of x. F of x is x cube plus 5. When you differentiate it, we know that constant and other rules, we have already done that. So differentiation of x cube is 3x square plus d by dx of this constant is 0. So you are getting 3x square. That means the differentiation or derivative of x cube is also 3x square, and differentiation of x cube plus 1 any constant 5, 6 or anything, that is also 3x square. But these two are not in agreement with this. That is why in general, when we define differentiation, integration of f of x dx is always is equal to f of x plus c. A constant has to be introduced. This constant will be determined based on the conditions given here in the integration. Usually the conditions given here as lower limit and upper limit, the initial conditions, all those things will be given. Using that we can determine. In general, this is the case. So one more part we will do, and that is, how do you get this from here? Because differentiation of this is this. From here to here, if you want to make a move, what all things you need to do, that we will do in the next video, and based on that we will actually explain the rules of integration, then we go on about it. So remember this, integral f of x dx is f of x plus c, provided d by dx of f of x must be equal to, or f of x plus c must be equal to f of x. So this is what, so the antiderivative, I mean the derivative of this is this, means the integration of this is this. That's what the meaning of integration as an antiderivative.